Application of seismic instrument. In this lecture, two application examples for the NPP, nuclear power plant, are discussed with their designs. They are SMS, Seismic Monitoring System, and ASDS, Automatic Seismic Trip System. SMS detects the seismic wave and provides alarms to the NPP operators. The operator then makes a decision whether or not to trip the nuclear reactor. ASDS has an automatic trip function. If the peak acceleration of the incident wave exceeds the predetermined level, trigger the reactor trip automatically. In the protection viewpoint, SMS provides alarms for the manual trip while ASDS provides automatic protection. The SMS consists of triaxial accelerometers and a seismic monitoring cabinet which is located in an electrical equipment room in Unit 1, only one unit. The cabinet contains recorders, a playback and analysis unit, an annunciator, a seismic switch, test units and an uninterruptible power supply. The signal flow from the accelerometer to the seismic monitoring system is shown in Figure 17. From the accelerometer, the voltage signal is transmitted to the seismic monitoring cabinet and is converted by electronics into a signal proportional to the acceleration. The acceleration signal can activate recorders and/or local and MCR annunciators/alarms according to its magnitude. When the acceleration of earthquake exceeds the seismic trigger or set points for OBE, operating basis earthquake or event, or SSE, safe shutdown earthquake, the alarm is provided on the local annunciator panel of the seismic monitoring cabinet and that of large panel display system, LDPS, in main control room or alternatively in the remote shutdown room. That event also activates the time history recorders in the seismic monitoring cabinet. SMS block diagram. ASDS continuously monitor PGA, peak ground acceleration, from the seismic wave and automatically generates the trip signal. As shown in Figure 18, the seismic signal detected by the accelerometer is filtered, rectified and converted to the current. The sensor module is to cut off the frequency ranges over 10 Hz in order to pick out the strong motion of the earthquake. Since the seismic signal has a positive and negative signal, a rectifier circuit is added. The rectifier converts the bipolar signal to the unipolar. Conceptual diagram of sensor module for signal processing. The overall scheme of ASDS is shown in Figure 19. The sensor output is interfaced with digital input card at the ASDS cabinet. Even the decision logic is set as 2 out of 4, but the system is composed of 2 independent channels. They are N1 and N2. For isolation between the channels, the digital input/output card is applied. The dotted line on the ASDS cabinet is the scope of trip logic channel N1 and N2. The ASDS cabinet is implemented by digitalized systems such as PLC, Programmable Logic Controller, FPGA, Field Programmable Gate Array, or DCS, Distribute Control System. The bistable and decision logic are configured with software inside each channel. Overall scheme of digitalized ASDS. The operational principles are as follows. When the measured signal exceeds the set point, the edge triggering happens and the status is set to 0 by comparator actuation. In this case, the latch is engaged due to the edge triggering, and keep the status for 10S. The purpose of 10S latch is to synchronize the individual channel for the coincidence logic. If the signals are not properly synchronized, the trip initiation signal may not be actuated during a strong earthquake. ASDS consists of 4 diverse channel applications. The bistable signal from each channel feeds into 2 out of 4 coincidence logic for generating trip initiation signal.